Hi everyone, in this video I'll be explaining the basics or the principle of remainder theorem, and I'll be solving few examples that is related to this theory. Okay, first of all, the main formula that we need to try to understand what is happening behind the principle of this remainder theorem. So as we can see, there is a formula here which is very important and is related to remainder theorem, where if we try to divide fx, a function fx, by something, for example, I'm just assuming it's x minus a, we will be getting the answer in respect to qx plus with r is the remainder. Okay, r is the remainder. In order for us to try to visualize what is happening here, I would like to compare this with the previous example that we did in previous video. Okay, so this was the previous example that I did in a different video, and in this example we were asked to divide this function with another function, and we got the answer with the remainder too, which means when we try to compare side by side, they're asking us to divide this with this, correct? Okay, so which means fx, okay, if I want to compare this example with our remainder theorem here, so fx is equals to, I'll rewrite it, fx is equals to this function, which is x to the power of 4 plus 3x cubed plus 6x squared plus 5x plus 5, and they're asking us to divide with this, correct? And the division, which is x minus a, right? So x minus a is equals to x squared plus x plus 1. This is just the representation. Okay, representation. All right, so once we divide fx with x minus a, which is x squared plus x plus 1, we got the answer in the answer we can just simply name it as another function, which is qx plus with r. This is also a function in respect to a, correct? So this qx, this function qx is this, okay, because we got the answer this, correct? When we divide our function fx with this, we are getting answer as x squared plus 2x plus 3, whereby if we try to relate it with remainder theorem, qx is actually equals to x squared plus 2x plus 3. Am I right? Okay, this is the answer that we got, and the remainder is 2, which means r is actually equals to 2. So if you try to put everything, the data that we got inside this formula, we'll be getting something like this. This fx is equals to x to the power of 4 plus with 3x cubed plus with 6x squared plus 5x plus 5. When we are trying to divide this with x minus a, which is x squared plus x plus 1, we are getting the answer, which is qx, which is x squared plus 2x plus 3 plus with remainder. The remainder is 2. So this is something that is happening if you try to rewrite the data that we got inside this formula. Okay, so what is the purpose of this formula? All right, it's very important for us to know. So let me divide so that I can show to you what is happening here. So this formula, I can rewrite fx is equals to this x minus a. I can simply bring it up. So x minus a times with qx, all right, times with qx, maybe I don't need this bracket, just let it be like this. Okay, times with qx plus with r. So this is the general formula to find the remainder theorem. So sometimes in the question they'll be asking us to find the remainder instead of the answer, which is qx. Okay, if we do the manual method, the one that I taught in previous video, we'll be getting the remainder as well as the answer when we try to divide something. Sometimes in certain question that is related to remainder theorem, they'll be just asking us to find the remainder, or they'll be asking us to check the value of a when the remainder is given. So when we want to find the remainder only, so we can assume x is equals to a. Okay, we can just take this bracket x minus a, we can just make it equals to 0. So x will be equals to a, correct? So when we substitute this a inside this formula again, what will happen? F open bracket, instead of x, I'm going to substitute with a. So a minus a times with qx plus with r. So a minus a is equals to 0, right? So 0 times qx will be getting 0. So we'll be getting the remainder straight away. So this is it's more like a shortcut, or more like a simpler method for us to get the remainder only. Okay, so what we can do, we can just take the x minus a, the one that we want to divide with, the denominator, all right, and then just find just make x as the subject, and move out the rest of the digit or unknown to the other side, and then substitute back inside the formula to get the remainder. All right. Okay, now let's try to do this example. Okay, they're asking us to find the remainder. You see, the remainder only again when the function fx is divided by the expressions in the bracket. So when we want to divide these expressions with the one in the bracket, we will be getting the answer as well as the remainder, correct? But in this situation, they are not asking us to find the answer. They're asking us to find the remainder. So whenever we were asked to find the remainder only, we can simply use the remainder theorem to solve it out. So from the remainder theorem, maybe I'll write this formula back, which is x minus a times with qx plus with r, correct? So we need to find this a right now. So let's look at example 17 right now. Example 17, x minus a is 2x minus 1, correct? So this 2x minus 1, we need to make it to be equals to 0, so that we can make the x as the subject and find the value of x. So x is equals to 1 moving to right, 2 we can divide, so it will become 1 over 2. All right, so what we need to do, substitute this x inside this fx one more time. Okay, when we are doing that, we will be cancelling this x minus a as well as this qx, therefore only the remainder will be left out. Let's try it out. So f open bracket, instead of x, we need to substitute with 1 over 2 equals to 2 open bracket 1 over 2 cube minus 3 1 over 2 square plus 4 times 1 over 2 minus 2. All right, so let's try it out. So 1 over 2 cube is equals to 1 over 8. Let me double check. Yes, it's true. 1 over 8 times with 2, the answer is 1 over 4. All right, so maybe I'll just write it one by one, easier for you. So 3 is equals to 1 over 4 when square it, plus with 4 divided by 2, correct, which is plus 2 minus 2. We can solve one shot, but I'm just like solving one by one so that we can avoid certain careless mistakes. So it's 1 over 4 minus 3 over 4 plus 2 minus with 2. So 1 over 4 minus 3 over 4 plus 2 minus 2. The answer is negative 1 over 2. So this is the remainder that we will be getting. All right. Okay, now let's continue to example 18. Maybe this time we can do a little bit faster. Okay, in example 18, let's find what is the x value. So 3x minus 2 equals to 0. Therefore, 3x is equals to 2 and x equals to 2 over 3. So if we try to substitute inside the formula, we'll be getting 2 over 3 equals to 3, 2 over 3 cube minus 2 over 3 square minus 4 2 over 3 plus with 3. Okay, so the answer is 1 over 3. You can try to check out with your calculator. So this is the remainder. Okay, remainder, or known as r. Okay, so example 17, example 18 is done. So example 19, example 20 is exactly similar method as what we did for example 17 and 18. So I think for 19 and 20, you can try out by yourself. And maybe if you still couldn't do it, maybe you can comment yourself in the comment section. So maybe we can discuss it in a separate video. All right. Now let's try to do a different example. Maybe I'll name this as example 2. Okay, when the polynomial function fx 2x cubed plus with 3x plus with ax plus 1 over 2 is, plus ax plus 2 is divided by x minus 1, the remainder is 8, and we were asked to find the value of a inside this function. So don't panic, use the same method again to find the remainder. So from this, it's x minus 1. If we make x as a subject, we'll be getting x is equals to 1, correct? So substitute this value inside this fx first. Alright, so f1 we'll be getting 2 1 cube plus with 3 1 square plus with a times 1 plus with 2, and the remainder is going to be 8. So just fill up everything and try to solve these two things in one equation to find what is a. So 1 cube times 2 is 2 plus with 1 square times 3 is 3 plus with a times 1 is a plus 2 equals to 8. So a is equals to, the rest we can just move it to right hand side. 8 minus 2 minus 3 minus 2 is going to be 1. A is equals to 1. So we found it already. So if you want to verify, we can also try to substitute this a inside, and then we can check whether are we getting the right remainder or not, because we know that fx equals to, when we try to multiply with x minus a, and then we are going to get qx. Wait a minute. We're going to get qx. Hold on. Qx plus with 8, correct? So which means if we try to substitute x with 1 again, when we try to substitute x with 1, we're supposed to get the remainder 8. So before that, we need to replace this a with the one that we got, which is 1. So let's try to do. So fx is equals to 2x cubed plus with 3x to the power of 2 plus with a, if we replace with 1, is going to be x, 1x, correct? Plus with 2, right? So now we can try to substitute the remainder x, the one that we're supposed to divide is x minus 1. So when we make x as a subject is 1, when you try to substitute this one inside this, we're supposed to get the remainder 8, right? So we can check this out also. Okay, so f, if we replace it with 1, we're going to get x1 1 cube plus with 3 1 square plus 1 plus 2. The answer is 2 plus 3 plus 1 plus 2. Yes, we are getting 8 again. So it is verified with the remainder that we got in the question. So the method to do this is very simple. Remainder theorem is very simple compared to the one that we did in previous video, where we need to divide it manually, and then we need to find the answer, which is qx, and also we need to find the remainder, which is r. This one's supposed to be r remainder, correct? Okay, so I hope you do understand, everyone do understand how to answer question that is related to remainder theorem. And please help me to like this video and subscribe to this channel. If you can, share this video with your friends as well, so that more people can get this free knowledge and they can get educated for anything that is related to mathematics and additional mathematics. And that's all from me. Thank you.